Welcome back to another AP Pre-Calc video. Today we're going to be looking at 3.4. This is all about just trigonomic functions and their graphs. Today we're going to be talking about just two functions. We will be analyzing first a cosine function, and then we will be getting into a sine function. Whenever we talk about these, we can say our parent function is y equals cosine of x. Few things to note about this. X is the angle of your function, and the value you're looking at, in this case y, is whatever you get when you plug in that angle. If I want cosine of some angle, that will always give us the x value at that coordinate. That might seem a little weird right now because I just said it was y. Okay, but we do need to connect those two. So if I want to start with this, let's look at cosine of some angle. Okay, the x values are the angles here. So if I have cosine of 0, well, cosine of 0, right? 0 degrees gives me the x value of 1. So we get the coordinate 0, 1 there. This will be 0, 1. Okay, and as we start to form this, we can go over to different coordinates and start to create our function. For example, if you went all the way over to pi halves, well, what would cosine of pi halves give us? Cosine of pi halves gives us a value of 0. And as you continue this, you could go to the other coordinates. Cosine of pi, what does that give us? Cosine of pi is -1. We could go cosine 3 pi halves. Cosine of 3 pi halves is 0. You could go to 2 pi, where the value, again, brings you back to 1. Okay? We might want some coordinates in between this to kind of figure out what's happening, because right now it just looks like a V shape. So let's find a few more coordinates as well. Let me just label these first. Okay, I'm not going to label all of them, just a few as we go through this. Looking at this, I see that we have pi halves, and pi is our intervals, but each of those are broken down into thirds. What that tells me is that each of these intervals then is pi 6. So this is pi 6. This would be 2 pi 6, which is the same thing as pi thirds. And now we could evaluate at those different spots as well. We could find cosine at those different values. Well, when we are at pi 6, we get an x value of √3/2. One thing you might need to know is √3/2 is roughly 0.866. It is irrational. It will have a never-ending decimal in this case, but it's roughly 0.866. So that would mean at pi 6, my function would be somewhere up here. Okay, and then at pi thirds, what we would end up getting is this x value of 1/2. And when we continue to go around, you could start to find those other values. At 2 pi thirds, we get -1/2. At 5 pi 6, we get negative √3/2. And those values just start to come back in play as we go around. What we end up getting is this function that looks something like this. Realize you could continue this function as you continue to go around a circle more and more times. And what you'd end up finding is it gives you a wave. Labeling a few more coordinates if you need it. Pi 6, √3/2. Pi thirds, 1/2. And then we went around to 2 pi thirds, which was -1/2. And then we went to 5 pi 6, which was -√3/2. So there's a few coordinates on there. Again, as you go around, it just creates this sort of function. Sine is very similar, but when we create our sine graph, The only thing that's going to differ is where the function starts, because the y values now is what I am looking at as I go around. So my first coordinate would be when I plug in an angle of 0 degrees or 0 radians, I get a y value of 0. So this coordinate is 0, 0. When I go to pi 6, I get to 1/2. When I go to pi thirds, I get to root 3 over 2. When I get to pi halves, I get up to 1. And then we would start to go down those same spots. And again, you can verify this on your own unit circle. And notice we get the same thing where it's this wave-like function, but the only difference is this one started at a different spot. One thing you're going to notice about sine is its starting spot starts at what we're going to call the midline, and one period of it looks like this. Versus cosine, it starts at the top of its function, goes down and back up to complete one period. Again, if you extend those out, it just creates some sort of wave like that. For cosine and for sine, same thing, it just creates a wave. Sine and cosine functions can always be transformed into one another simply by just using a horizontal shift. That's the only way they're different, is they're just shifted horizontally from one another. So we have both of our functions here, just creating a cosine and sine function. But let's talk about the anatomy of these different things. You probably heard I threw in some words on this last part, but let's go ahead. Let's copy down our sine function. We're going to do this for sine real quick. Again, we saw that sine started at the bottom, or at the midline is what I called it. It starts in the middle of our graph. We saw that at pi halves, it got up to 1. At pi, it got back down to 0, -1, and 0. So it looked something like this, as it was a wave going up and down. If you were to go backwards on your circle to get these negative angles, it would just do the same thing, but in reverse then, giving us our function now like this. Whenever you look at these functions, there's different words that you're going to have to get used to. One of those words is amplitude. Amplitude is simply the distance from the midline to the maximum or minimum. Well, first thing we might need is just, what is the midline? The midline is the spot where you can cut your graph in half horizontally. So if I can cut my graph right here, this blue line is the midline. From the midline, the amplitude is simply how far from the midline to the maximum or the minimum. This distance here is the amplitude. I'm going to write amp for that. That distance would be the exact same as if you were to look at it for the minimum spots. That is also the amplitude here. Amplitude is simply how far from the midline your maximums and minimums are. The period then is the next word that I am seeing. A period for your function is simply how long does it take for your function to repeat. It's the horizontal distance to complete one cycle. You can measure this from a few different spots. We said that sine starts at the midline. So I'd want to know, okay, if my sine function starts right here, how long does it take to get back to that same spot? Well, my sine function goes up, it gets back to the midline, but it hasn't completed one cycle yet because it hasn't finished it going down and then returning to it. If I look at it from the midline, it must go up, down, and then return. One period could be measured from here to here. This is a measurement of a period. You don't have to measure it from the midline, though. You could measure period from your maximums or minimums. For example, if I wanted to measure a period from the minimums, it's just how long did it take to go back to this spot. Same idea with the maximums. These would all give you the same measurement. A phase shift is not shown in this diagram. A phase shift is simply the horizontal shift. Sometimes you'll have a horizontal shift, or sometimes you just change the type of function, sine or cosine, to get rid of that phase shift. We know range. Range is just the minimum comma the maximum. In this case, our range for the function above, we knew it got down to -1 and up to 1. But again, that is really just minimum comma maximum. And the range we know is all real numbers. These functions can go on for infinity in either direction as you just continue to go around the circle more and more times to plot these different wave functions. Knowing these words then, one thing you might want to add to your notes is breaking down the sine function a little bit, creating the transformation form of it. We know that our transformation form would look like this based off of the parent function. Few different components then. Your amplitude is the A value. Your B value is simply found by taking 2 pi and dividing it by the period. I'm going to do that in dark blue there because it is related to the period. That was not dark blue. Period was a different color, my fault. Okay, B equals 2 pi over P. I'm going to say P is the period. The midline then is simply where your vertical translation comes in. This is the same thing as the midline. And then we did see our phase shift is the H, that is the horizontal translation, horizontal shift. Okay, that is breaking down these functions. So now using this function or this form for the transformations, we can start to identify different information. For example, this next graph, I do want to identify each of those components. I need to know the period. I need to know whatever that was. I need to know the period, the amplitude, the midline, the domain, and range. We want to identify each of those components. Amplitude, period, phase shift, we may or may not have one. In this case, we're not going to necessarily look at one. But I do need domain, I need range, and I want the midline. Well, I think the easiest one to start with is midline because that helps you just visualize all of this. So the first thing I want to do is just figure out where can I cut this graph in half. Well, the top of it's at 3, the bottom's at -5. That would mean the middle of it is at -1. So I know the midline is y equals -1. It is a line, so make sure you have x or y equals. It's a horizontal line, so I need y equals. From there, I think it's pretty easy to identify the amplitude, because the amplitude is how far up or down from the midline do we go. Well, if I'm at -1 and I get up to 3, the amplitude would be a value of 4. That would be the same whether you're looking at the midline to the top or the midline to the minimum. We can then look at one period length. One period length is how long does it take to reset. Different ways you can look at that. One way is you might just look at the top coordinates and how long does it take to do this distance. For example, we want to know how long does it take to go from 5 pi eighths to pi eighths, and you could subtract those to find it. That would give us 4 pi eighths, which is just pi halves. Our period in this case is pi halves. Realize that distance could also be found on the midline to see when it resets. That'd be from 0 to pi halves. You should see the same value there. Your domain, we know the domain is all real numbers, so we already know that. Domain is just all real numbers. And the range, what is the minimum? It looks like we get down to -5, we said. And how far up do we go? It looks like we said that was a value of 3. There is finding each of those components. Let's continue to one last part. Given a graph y equals a cosine x plus c plus d. What is the value of d? Remember that vertical shift on the outside is just how far up did you move your function? Well, wherever the midline is. The midline is normally at 0. So however far up the midline is would be our answer here. Looks like our midline is right here, where this would be a value of y equals 6. So I believe we get our answer there, where the d value is 6. The last one on here then says, what is the phase shift of the function? A lot of people mess this one up. A lot of people just want to say, okay, it goes 2 units to the left. But that is not correct. The reason this is not correct is whenever we talk about transformations, we always like it in our factored form. So I would have to factor whatever the coefficient on x is. So I can take pi out, meaning I divide pi out of each of the terms. I divide pi x by that value, and I divide 2 by that value as well. Now when I look at the horizontal translation, I end up noticing it is going 2 over pi units to the left. Thanks for watching. That is our 3.4 trig graphs lesson.